In question 2, we want to topologically sort the same graph from question 1. So just a quick refresher, topological sort is a sort such that for each directed edge, u to v, u comes before v in the sort. So if we were to think of this in the context of different courses, an edge from class A to class B means A is a prerequisite of B. A topological sort is an ordering of classes to take, such that when you take a class, you've already taken the prerequisites. So how do we find the topological sort step by step? So in step 1, we find a node with no incoming edges. These nodes are referred to as sources, so the first vertex in a topological sort must be a source. In step 2, we process the vertex, then decrease the in-degree of its neighbors by 1. And you can do this by either removing the node from the graph altogether, or manually decrease the in-degrees of its neighbors. In step 3, we mark the node as visited or processed, and then in step 4, we repeat, starting from step 1 until all the nodes have been visited. Let's begin by labeling the in-degree of each node, which is just the number of incoming edges. So the in-degree for A is 0, the in-degree for G is 0, the in-degree for D is 1, and so on. The algorithm has us first choose a node with in-degree 0, process it, and decrement the in-degree of all of its neighbors by 1. So we have two nodes with in-degree 0 right now, so let's just pick one arbitrarily. So G gets added to our sort, and G has one neighbor F, so we decrement its in-degree by 1. The next node with in-degree 0 is A, so we process that, and decrement the in-degrees of its neighbors B and D. The next node with in-degree of 0 is D, and we decrement in-degrees of B, F, and E. Next, we once again have two nodes with in-degrees of 0. Let's just pick E. And in doing so, we decrement the in-degree of F. Next, we process B and decrement the in-degree of C. Then we process C and decrement the in-degree of F. And our final node left is F. And our final topological sort is G, A, D, E, B, C, F. So something to take note of is that this is just a reversal of the DFS post-order traversal. Also, there are many other valid topological sortings. This is just one of them. So the last part of question 2 asks for the two requirements that a graph must satisfy in order for there to be a valid topological sorting. So the first one is that the graph must be directed. And this makes sense since you cannot impose an ordering of the nodes in the graph if it is undirected. The second is that the graph must not have cycles. If a cycle were to exist, for example from A to B to C and back to A, there's no way to determine which node should come first. And graphs that satisfy both properties are called directed acyclic graphs.